Hello everyone, I am Pragya Paramita Meher. I am currently pursuing my Masters from University of Hyderabad. I will teach today's Pinacol Pinacolone Rearrangement. It is class 11th Organic Chemistry topic. So now we'll see what is Pinacol. Pinacol is a 1,2-diol. Now this Pinacol interact with one acid catalyst, or you can use directly a acid, sulfuric acid or hydrochloric acid. Now this hydroxyl group's lone pair will attach to this protein and it will form hydronium ion H2 plus. After this main step will happen, the formation of carbocation. This OH2 takes the electron to itself and removes out its water, and now it will form carbocation. After that, this carbocation has to stabilize. As here hydroxy group is there and lone pair of this oxygen can gives electron to carbocation for stabilization of it. So how it will happen? Carbocation, how it will comes to here? By methyl shift. So if we shift this methyl to here, then carbocation will be going from there like this, and this methyl will be here. Now this will be the most stabilized carbocation. So this hydroxyl gives electron and it will form pinacolone. Plus, and this bond gives back, and our catalyst will be regenerated. This is catalyst. Pinacolone. Pinacol to pinacolone. This is the mechanism. Now, this is the mechanism only, but in entrance exams, substituted pinacol will be asked for that. So we have to see some another examples. Now, for that first example, if in presence of 2-methyl, anyone will be substituted, then what will happen? Like this. Then where the carbocation will form? At which position carbocation will form, so that it will more stabilize, you have to see. If carbocation has to form here, then this hydroxyl will be not there, it will more stable, or here carbocation will form. Which one will be more stable, you have to see that. So H phenyl is gives electron by plus R or plus M, and it's aromatic in nature, so it will more stabilize the carbocation. But in methyl, if only here carbocation will form, then it will stabilize only by plus I effect. So this position carbocation will be more stable. So here will be carbocation will form. Now this will affect to here. H2 plus, it will give water, form carbocation. There also we have seen where carbocation will be stabilized, but after that we have to see now if carbocation will form here, then it will more stabilize by taking lone pair of this oxygen. It will more stabilize the carbocation. So we have to do any shift so that it will form more stable. Now that's why this methyl will shift. 1 to methyl shift. 1 to methyl shift and its form. Now this lone pair gives electron back. It will form Pinacol. This example 1. Now we'll see if this two groups are same here. Here if other substituents are there. Now both are not same. Then which one will migrate? As here both two groups are same, so methyl any methyl can shift. But if others, then what will happen? Let's take one pH will be here and one CH3. Then here we have to see migratory effect. For migratory effect, first phenyl will shift, then only alkyl. In place of alkyl also 3 degree first, 2 degree, then only 1 degree, then only methyl shift happen. So now let's say 2 phenyl here. Okay, then here also carbocation form, then it will more stabilize in place of here. So we will form carbocation here. I am directly giving carbocation without hydrogen. Just step I am skipping. Now we have to see where the carbocation forms so that it will more stabilize. Here by giving electron from this oxygen, it will form more stabilized carbocation. So carbocation can be formed here. Now we have to see migratory amplitude. So here two groups are there, phenyl and methyl. Which one will be migrate? As I said, migratory amplitude, phenyl will shift first. So that we have to migrate phenyl here. How phenyl will shift? We will see by opening phenyl group. Now by opening, let's say like this. This double bond will attack to this carbocation and it will form species like this. Like this. Now this bond gives back electron to this bond. And phenyl goes back to another carbon. This phenyl also here. And carbocation form here. So that after this step, this hydroxyl group gives electron back and it will form Pinacol. pH, pH, pH. Now this is example 2. Now another example, example 3. It is a ring expansion example. um, for to form stabilized carbocation, here ring expansion will happen in this type of examples. So now same protein it takes here OH and here the carbocation will form. Mm, and to stabilize carbocation, this bond it take here. Now now this will happen. Ring expansion happen. And it will form this electron pair. Mhm. Now 5-member rings become 6-member. 5, 6. And in second position, double bond will form. We can write like this also. This will form. With this, we will complete Pinacol Pinacolone rearrangement. Thank you.